Hey everyone, how's it going? Welcome back to InfoGamer. For this lesson, we're going to be talking more about the transform component of game objects. And for this video, we're going to be focusing on the information you need to know about the transform component with regards to the Unity editor. If you want to find out more about scripting with the transform class, you can click on the video that will be linked at the end of this video. It'll also be found in the description below. Alright, so here we have our tutorial project open inside of Unity, and the first thing that I want to talk about is the 3D environment that Unity generates and provides for us in order to help us build our video games. And we can see into that 3D environment through our scene and game windows. Now I don't want to spend too much time going over what 3D means because many of you probably already know what it means, but for those of you that don't know what it means, 3D stands for three-dimensional, which means that we have three different directions in our environment. Now, just as we're living in a three-dimensional world in real life, where everything has volume to it, that is, everything has a height, a width, and a depth, so does your environment inside of Unity. So here we can see inside the scene view that we have this grid pattern laid out. Now, this grid is representing the width and depth of our environment. And as we move our camera around, we can get a feel for the height dimension. Now, these three different dimensions inside of Unity are referred to as the X, the Y, and the Z dimensions, where X represents the width, Y represents the height, and Z represents the depth. Now, it's possible to create two-dimensional games inside of Unity, but Unity is a 3D game engine. And so when you're creating a two-dimensional game, what you're really doing is you're just using your camera to only capture two dimensions, that is the X and the Y. Now the next thing that I want to talk about with regards to the 3D environment that Unity provides for us is what's called global and local space. Now every single scene that you ever create inside of Unity has what's called global space. And global space is where there is a center point to the entire environment of your scene, and that is located at position 000. And so for example, in our last video we created an empty game object, which I have right here, and inside the transform we can see that the position of this game object is located at 000. So currently this game object is located at the center point or origin of our scene. Now we can't just have a single point and call it three-dimensional. We have to have the three dimensions in order to have a 3D environment. And so from the origin point at 000 extends our three different dimensions. So we have a positive x direction, a negative x direction, a positive y direction, a negative y direction, a positive z direction, and a negative z direction. Now global space is where all of the coordinates of our three dimensions are always going to be the same. So the center point of our scene is always going to be located right here, and then positive 1 in the x direction is always going to be located right here, and so on. Local space is where the origin of a game object is located on the pivot point of that game object, and then the dimensions from that game object extend out in the x, the y, and the z directions. Now if I were to rotate a game object, so would the transform of that game object. And so you can kind of tell the difference between global space, which pertains to the scene itself, and local space, which pertains to the object. Now anytime you have a game object that's not a child to another game object, the transform of that game object as displayed in the inspector will be in world space. Now currently our empty game object is located at the origin of our scene. Now if I were to change the x value to say 1, then you can see how the location of our game object has changed. Now the local space of this game object says that the origin of this game object is still located on this point. So the local space for this game object says that the 000 value of that game object is located right here. But the world space location of this game object is 1 in the x direction, 0 in the y direction, and 0 in the z direction. Now if I were to create a new game object, and this time I'm going to create a 3D cube, and if I were to attach this 3D cube to our empty game object so that it is a child to our empty game object, then inside the transform, you'll notice that the location of this cube is at 0, 0, 0, even though it's not located at 0, 0, 0 in world space. That's because the transform of a child object will be in relation to the local space of the parent object. Now the transform of this cube object is pertaining to global space, and so the global location of this cube is located at 2x because we had it at 1x for the parent object, and then we moved it over one more x, and that puts it at 2 for the global space in the x direction. Another feature that's important to note about parent-child relationships is that if you have one object as a child to another object, and you move the child object, nothing will happen to the parent object. The parent object will always stay where it is located. But if you were to move the parent object, you can see how the child object moves in the same way the parent object works. Now that we have a better idea of how this 3D environment works inside of Unity, let's talk about some of the transform tools that Unity provides. So up here in the top left corner above my scene window, you can see these 5 different buttons and then these 2 other buttons. Now this first tool on the far left is what's called the grab tool. This tool can also be selected by pressing Q on your keyboard, and this tool is used for moving your scene view camera. So if I left click while having this tool selected, you can see that I can move my camera to the left and the right and up and down. Now I don't use this tool very often because I can use the same functionality by just middle mouse clicking, or that is clicking in the wheel of your mouse and dragging the mouse around. Now the next 3 tools are standard 3-dimensional transform tools. And let's look at this diagram here. On the far left, this is the gizmo that you'll see when you have what's called the move tool or position tool selected. Now when I have this tool selected inside our scene view, you can see the same gizmo appear here on the origin of the game object. Now each of these 3 different colored arrows represents one of the 3 different dimensions that we have. So the red arrow is for the X dimension, green is for Y, and blue is for Z. Now each of these 3 different transform tools can be used in global space and local space inside our scene. And so to have it set to global, you want to make sure that this button on the far right says global in order to move your game object within the local space of that game object. You want to toggle this button so that it says local. You can also change whether you want to move the object based on its pivot point, which is the origin, or its center point, which is the center of mass. So here I've made a second cube object, and I've made it a child to the first cube object. Now when I have the first cube selected and this option is set to pivot, you can see how the tool is in the center of the first cube. Now if I change this to be center, you can see how the transform tool moves to be right in the middle in between the 2 different cubes. So it's from the center of all the objects that encompass the parent object. Now as I use the move tool to reposition my game objects, you can see within the transform component of the inspector how this tool modifies the position of the transform of that game object. So as I move the game object in the scene view, the value of its position is displayed in the transform. The next tool available to us is the rotation tool, which is located right here. You can also select this tool by pressing E on the keyboard. Now let's go back to that picture that I showed you. In this center image, you can see that the rotation tool looks like this, and that's the same image that we're seeing here inside the scene view. Now this tool looks like a sphere, and the sphere has 3 different colored lines going across it. Now each of these 3 different colored lines correspond to, you guessed it, the 3 different dimensions available to us. So just like the move tool, the red is for X, the green is for Y, and the blue is for Z. Now it takes a little bit of time to get used to the rotation tool because what it's doing is it's using the 3 different dimensions as axes to rotate around. So you can think of each dimension as like a pole going through your game object in which you can use to spin that game object. Now just like the move tool, as I rotate my game objects inside the scene view, you can see within the transform component of the inspector how that affects the rotation of my game object. And the reason why all the numbers are changing is because I'm not rotating this game object based on its original rotation being 0, 0, 0. So if I change this rotation back to 0, 0, 0, I can then grab the x-axis and rotate it, and then only the x value of the transform component is changing. The next of the 3D transform tools is the scale tool. You can click on it here, or you can press the R key on the keyboard. You can see how the transform tool has now changed to these 4 different boxes, which matches this far right image for the scale tool. Now, just as you can guess, the 3 different colored boxes work the same as the 3 different colored arrows for the move tool and the 3 different colored lines for the rotation tool. The white box in the center is for scaling the whole game object in all 3 dimensions at the same time. So let's go ahead and grab our cube object, and I can scale our cube object in the x direction, and you can see how it only stretches in the x direction. And then I can stretch it in the z direction, or shrink it in the z direction, and I can stretch it and shrink it in the y direction. And as I scale my game object within the transform component of the inspector, you can see how that modifies the scale of our game object. Now, the last tool available to us in the top left corner of our workstation is the free 2D transform tool. So you can select this by clicking this button here, or press T on the keyboard. Now, this tool works best if you switch your camera's perspective to 2D. So I'm going to go ahead and click the 2D button at the top left of our scene view. Now you can see how there's blue circles in the corners of our cube, and this makes it possible so I can change the dimensions of my cube and the position of my cube in 2D space. Now, it's perfectly fine to use this tool to modify 3D objects, as I am here, but most of the time you're going to use this tool to modify 2D objects such as sprites or UI images. Now that we've gone over all the different transform tools available to us inside our scene view, let's go over to the inspector and talk about the transform component. So here inside the inspector, you can see our transform component, which is located right here. Now at the top, we can see that it's labeled with transform, and next to the label, we can see an icon. Now this icon represents the transform component. Now, just like the move and scale tool have the red, green, and blue options, this icon has red, green, and blue lines all coming out from a center point. So whenever you see this icon, you can know that it is referring to the transform component of a game object. Now, below the label of this component, you can see 3 different elements that make up the structure of the transform class. And those 3 different elements are the position, the rotation, and the scale of a game object. Now, all 3 of these elements are made from what is called a vector 3. A vector 3 is a data structure of its own that's constructed from 3 different values. And those 3 different values are most often floats, but can also be integers. Now, because we have 3 different elements, position, rotation, and scale, and each of those elements have 3 different values, we have a total of 9 options within the transform component of the inspector. Now remember that when you have an object selected inside your scene and that object is not a child to another object, then the transform of that object will show the global transform. But if you have another game object, such as this cube, that's a child to another game object, then the transform will display the location of that game object in relation to the local space of the parent object. Now, just as you can use the transform tools to modify the location, the rotation, and the scale of game objects inside your scene, you can use the inspector to manually enter in the position, rotation, and scale of that game object. Now, let's say I wanted to position our cube at the location of 5x, let's say 10y, and -5 in the z direction. So you can see that this empty game object representing the center of our scene, our cube game object has been moved to position 5 in the x direction and 10 in the y direction and -5 in the z direction. So as you directly modify any of the options inside the transform of a game object, the same modifications will take place within your scene view. Now that's everything that we're going to cover in this video. I hope it was helpful and that you learned a lot about the transform component of game objects. I would highly recommend that each of you play around with the transform component, get really familiar with it, because it's super important that you know how to use it in order to create video games. Now, if you want to find more information about scripting with the transform component, you can click on the video at the end of this video. If you have any questions regarding the transform component, you can leave them in the comments below. Also, make sure that you like this video and subscribe to our channel so you can get regular notifications when we release new videos. Thanks for watching, and we'll see you next time.